There's antimony, arsenic, aluminum, selenium, and hydrogen.
For fires, we have a couple different features that are located over here. The first is a fire blanket. The fire blanket is something that can be used to smother oxygen away from the fire because a combustion reaction uses oxygen as one of the ingredients. So this fire blanket can be put onto a sleeve, it could be put onto a pile of papers that are on the desk, and then you can smush that down. We don't want to stop, drop, and roll in the lab necessarily because stop, dropping, and rolling might cause you to bang into other things. If you happen to get any chemicals in your eyes, we have an eye wash station that's located towards the front door of the classroom. You might not be able to see because your eyes are irritated, so be prepared to grab the arm of a peer and guide them over to the eye wash. The eye wash is initiated by simply pressing down on the handle. When the water comes out of the eye wash, it's going to flush over the mucous membranes of the eye. Note that for our particular models, the water that comes out is going to drain into the floor, thereby causing a slipping hazard. This is not a toy. Make sure you only use it if it's necessary. If you get a small abrasion or paper cut, we do have a first aid kit. These are supplies that you're allowed to use if you ask your teacher. We have gauze, we have Band-Aids, we have medical tape. We will also call the school nurse and or 911 if we have a larger emergency. And then our fire extinguisher is clearly marked by the front door, as is our fire evacuation plan. These fire extinguishers are checked by the Mount Lebanon Fire Department so that they are full. They are not a toy. We only use them in the event of a true emergency. This is a shared goggle cabinet, so if you are assigned goggles, you will take them to and from class, but this allows goggles to be used multiple times throughout the day. The goggles are all rated against splashes, and to make sure that there's proper ventilation, they're able to fit over top of eyeglasses as well. When you adjust the goggles, make sure that you very gently and slowly move the straps that are on the side of them. We don't want to yank these straps. They actually break quite easily. We slide them over top, covering above the eyebrows and the side of the face. When they are done, you slide them back into the goggle cabinet, close and lock the door. The key just stays on there, and then we can turn on the UV light to disinfect. In the lab, we want to protect our clothing. We can accomplish that by either wearing a laboratory coat or by adding a laboratory apron. Our aprons are just simple tie-ons. They slide over your head, and then to make sure that the apron doesn't get stuck on anything, you want to put a bow at the back. If you add a knot, it could become difficult to remove that whenever class time is over. If anything spills on this apron, I'm able to wipe it off, and it's also going to protect the skin and the clothing underneath. The next thing that we're showing you is the fume hood. This is for anything that we're using fire or volatile liquids, things that might irritate our eyes or our nasal passages. We're able to put ventilation that's going up out of the classroom so that it doesn't build up in the room. Make sure that you follow your teacher's instructions when utilizing this feature. We have the ability to turn off our gas supply in the lab. There's an emergency shutoff so that we have any Bunsen burners or methane being used that we can stop that. If you ever break glassware in the lab, make sure you alert your teacher. We'll probably ask you to get one of the lab brushes and dustpans and simply sweep up any of the broken glass and then put it into one of these trash receptacles. Notice that I'm using a specialized one and not the regular garbage can. We don't want anybody to get cut. This is also the location that we would put used matches so that we don't accidentally catch paper in the waste pan on fire.
So here we have station 1. So for A, we have our box of matches here. So you can open up the box of matches, take one out, and obviously to light it, and strike it across the top. For B, we have our test tube rack. So our test tube rack has 12 holes in the top, and it can hold 12 test tubes very easily. You can set them down in there when you're not using them at a given time. For C, we have our test tube brush here. Test tube brush fits nicely inside our test tube. It can be used to clean it out. For D, we have our safety goggles. I'm already wearing mine. Safety goggles obviously go right on your face and stay there whenever you're working with any chemicals in the laboratory. All right, for E, we have our test tube holder. So our test tube holder is spring-loaded basically, and you clamp it around the test tube, and that allows you to pick up the test tube and move it around. Make sure that you're never pointing the test tube at anybody and that you are holding it firmly. For F, we have our Bunsen burner here. So we have these mini burners. It's currently hooked up to the gas over here by a tube, and that Bunsen burner allows us to have a sustained controlled flame. For G, finally, we have our test tube. And our test tube is a glass vial that can hold chemicals. Reactions will take place in it. Also, you'll notice about this test tube here that it actually has some broken glass around the rim. So we wouldn't actually want to use this test tube, but for our purposes, we want to show you that. So our first step at station 1 is going to be to light the Bunsen burner. Before you light a Bunsen burner, you should always remember to have your safety goggles on. So I have mine on, good to go. All right, so what you want to do when you light the Bunsen burner, first you want to have your match ready in your matchbox. Second, you're going to want to turn the gas on. So to do that, you flip the gas to the middle position. So you have the nozzle and the handle lined up together. You'll hear the gas coming out of the Bunsen burner. You want to make sure your windows on your Bunsen burner are open so the oxygen is flowing, and that you want to have the gas turned up so you can hear it flowing. Okay, I can hear the gas going, so now I'm going to take my match, strike it, and light it. And you should be able to see that the Bunsen burner is lit because you have this blue flame coming out of it. So when you have a Bunsen burner, a couple things to notice. There should be, might be hard to see, but there are 2 cones of blue flame here. You want to have an inner cone of blue flame and an outer cone of blue flame. You don't want to see it get too tall and high, and you don't want to see any orange in your flame. You want to have it nice and compact in those 2 blue cones of flame. All right, next we're going to take our test tube here, okay, and we're going to fill it about 1/4 full with water. So I can go to my nearest sink and just fill that about 1/4 of the way with water. If you're going for a really precise amount, you might want to use a wash bottle here, but we don't care if it's exactly precise. Okay, so for the next step, you're going to use the test tube holder. Again, this test tube holder here is kind of spring-loaded, so what you want to do is grab the test tube near the top. You always want to grab it by the top and hold it there. It's pretty secure. You can firmly hold it this way. Okay. Next, you want to hold the Bunsen burner in the tube for about 30 seconds. So when I do this, I'm putting the bottom of the test tube right at the tip of that inner blue cone. I'm going to kind of move it side to side, brush the test tube to try to heat it evenly. And when I heat this, I need to think of a few things. Okay? First thing I think of is that I'm never pointing the opening at myself or anyone else, because when we heat this, what's going to happen is it's going to start to heat up. Potentially boil, and if it does that, it could potentially splash and it could shoot hot chemicals at people if it's pointing at you. So you never want that to happen. You never want it pointing at anyone else. So we're going to take some time to heat this, and you can see it starting to boil. You can see some bubbles starting to form, and you can hear it now too. So it's starting to boil, and we're going to take it off. So this is going to be very hot right now. Obviously you don't want to touch it, so the safest place to store it is this test tube rack. So you're going to put it in there, clamp down on the test tube holder, and let it go. So it's safe there now. It's not going to hurt anybody. And now that we're done heating our material, heating our test tube, we're going to turn the Bunsen burner off. You don't need to reach, touch any part of this Bunsen burner, turn it off. All you need to do is flip the gas right off, okay? So when you flip it off, you make sure that the handle and the nozzle are not aligned. You flip it to either side, and then the gas is turned off. Okay, so after about 1 minute, the test tube should be cool to touch, so we're going to wait a little bit longer to touch that. And when you do that, you can place the back of your hand onto the test tube and touch it to make sure that it is cool, and it is not heated. Okay, so now that our test tube is cooled down, we're going to take our water, just go ahead and dump it in the sink. Now we're going to wash our test tube. Obviously, when you just use water in a test tube, you don't have to worry too much about washing it, but we're going to do it just to show you. So you're going to take some detergent and squirt it in the bottom there. You can fill it with a a little bit of water, and then you're going to use your test tube brush to kind of clean it out. So this test tube brush, again, fits nicely in the test tube, gets all sudsy, and you'll kind of wash that out. Take a couple times to rinse it, and then once it is washed, you will put it back into your test tube ring.
At Station 2, we're going to learn how to weigh out solids, measure out liquids, and then mix a solution. So as our solid, we have a very common table salt, NaCl, sodium chloride. When we weigh that, we put it onto a special thing that's called weighing paper. So salt is letter A, and then the weighing paper is letter B. The weighing paper gets put onto an electronic balance. You might have seen those really fancy balances that are mechanical, but we use ones that are very precise, and then they will read to decimal points. The electronic balance has a cord that will be plugged into the nearest outlet. Whenever you use these in lab, you'll want to match up the cord to the device. It just simply plugs into the back, just like you would charge a phone or another electronic that you have at your house. When we stir solids into their liquids, we have stirring rods. They typically are glass so that they won't react with the chemicals that we're utilizing. Letter E is a spatula. The spatula will be used to scoop the solid, like the salt, onto the weighing paper and to distribute it into the proper receptacle. And then we've got the graduated cylinder, letter G. The graduated cylinder that I'm holding right here holds 100 milliliters, but there are various sizes. We tend to like to use the plastic ones because it's less likely that it would break. We're first going to weigh out our solid, which is sodium chloride, NaCl, a type of salt. In order to weigh that out, we need to plug in our electronic balance. The connection is simply on the back. We put the adapter in. There is a button that says on/0. If you press that, you'll notice the digital display begins. You want to wait until it says 0.00. If there's ever dust on here or if something gets messed up, you can always hit that button one time again and the display should default back to 0.00 grams. I'm placing one piece of weigh paper. This is a single time use only paper, so if it gets dirty, I can simply dispose of it. I'm going to open up my solid and then get my spatula. With this, I want to make sure that I'm not counting the weight of the weighing paper. So now that that's on there, I should hit 0 again. I want it to only count the salt that I'm sprinkling on. I'm being very slow about this. If I dump a bunch in, I can't put it back into the stock container because that would contaminate it. So I need to try to get this as close to 0.50 as possible. Notice that I actually went over. I cannot take anything from the weigh paper to put back into that bottle. So what you can do is you can simply dispose of that into a little receptacle that's off to the side. So I'm gonna sprinkle a little bit of that on. And I'm pretty close at 0.48. In the instructions, it asks me to take this amount of solid and put it into my beaker. You can simply fold this like a cute little taco, and then you just use that as a funnel to pour it into your container that you're stirring. I need to add this half a gram of salt to 30.5 milliliters of water. So I'm gonna turn on my water. I turn it on very slowly to make sure that it's not splashing everywhere. And then just tilt the graduated cylinder to the side. When you're using a graduated cylinder, you are going to look for a little scoop at the bottom of the liquid that's called the meniscus. And then you're going to put yourself at eye level to make sure that that little scoop lines up with your measurement.
Wow.
And so I have it at 30.5 milliliters right now. I will stir this together by using my non-reactive glass stirring rod. This is a solution. It has a solute mixed into a solvent. If you're using warm water versus cold water, you'll notice that it's easier or more difficult to get this to dissolve. When you're done with the station, you would simply dispose of the contents. You would want to make sure that you rinse everything very well and then use detergent in the lab if your teacher asks you to do so.
All right, everyone, so now we're at station 3. So at station 3, we're going to be practicing filtering a mixture of a solid and a liquid together, trying to separate them from each other. So to do that, first tool that we have, letter A, is our funnel. So you've probably seen a funnel before, but what it lets it do is you can have filter paper in here, and it'll trap your solid and let the liquid run through. So this is A, the funnel. For B, we have our watch glass. This is a little concave curved piece of glass. You can see it kind of has that curve, and it's good for setting things onto it, setting it on material, and it holds them there. Okay. For C, we have our iron ring. So this iron ring goes onto what we call this ring stand here, and you'll basically put it on, and it'll let us hold things aloft. It'll let us hold things in the air on that ring stand. D, we have our little 50 milliliter beaker here. Again, beakers are good for holding liquids, not necessarily as good for measuring them, but for holding liquids, they're a perfect tool in the chemistry lab. E, we have our packet of filter paper here. Our single piece of filter paper here, you'll see, is just a big circle. When we actually use it with the funnel, we're gonna fold it up so that it looks a little bit different and fits really nicely in the funnel. And that will allow, again, our liquid to pass through, but not our solid. For F, we have our clay triangle here. So our clay triangle F, it's really good at holding that funnel in place on that ring stand. So again, we'll use this in conjunction with the iron ring and the ring stand and the funnel to hold that funnel in place. For G, we have this thing that we call the ring stand. So G here, and that ring stand again is for holding that iron ring and keeping things held aloft in our lab. And lastly, letter H we have here is our wash bottle. We use the wash bottle to administer water to either clean things out or to wet things down. All right, so now we're at station 3. We're going to go through our procedure. So the first thing we want to do is start setting up our apparatus here. So we're going to take our iron ring here. You have the screw at the top of this iron ring, and that allows us to slide it onto the ring stand and fasten it on there. So we'll tighten the screw until that iron ring is nice and solid on that ring stand. And that's again going to allow us to hold things aloft and allow gravity to do its work. Next, we're going to take our clay triangle and put that clay triangle onto the iron ring. And that again will just give us an even better way to hold this funnel. This clay triangle is especially useful if you're holding something like a crucible. So if you have a crucible in which you're heating something, this holds that crucible really well. So we're going to put the clay triangle on there. Next, we're going to take our funnel and put it into the clay triangle. And you can see our apparatus here is holding that funnel nicely. All right, the most complicated part about using a funnel is actually applying the filter paper correctly and using it correctly. So you'll see it's a big circle right now. But what you actually want to do with it is fold it in half, and then fold it in half again. So you have a quarter circle for this filter paper. And so what you can see now is when I kind of squeeze this together and pop it out, you have this nice little funnel-shaped piece of filter paper here, and that's going to fit very nicely into my funnel right here. Okay. So when you do this, anytime you're using that funnel and that filter paper and you're going to be draining a liquid through it, in order to get it to completely stick, what you're going to do is take your wash bottle and kind of wet that filter paper. Okay. You're going to wet that with a little bit of water, and that's going to allow it to stick to the funnel a little bit better and get it wet for when you're actually going to be putting water and sand through it. So next, you're going to take this 50 milliliter beaker, which I've already actually done, and put it below the funnel. But what you'll see from where I just wet it is that it's actually dripping down, kind of splashing everywhere. It's a much better technique if you actually take the iron ring and lower it down a little bit so that the funnel is right above that beaker. That way you're not going to have a lot of splashing or problems with that funnel draining too far down. Okay? So now that you have your apparatus set up, it's in place, you have it adjusted to the correct height, you're going to take your mixture of water and sand, which I have right here, and you're going to start separating it using this funnel and this filter paper. So I'm going to take my water and sand and start pouring it through filter paper. Now when I do this, I don't want to dump it all at once, because if I do, the water's going to take up too much space and come out of the funnel. So I want to put in a little bit at a time and let it drain slowly into that beaker. Start separating that liquid out. Okay, so now that I've waited until all that liquid drained from the filter paper into the beaker down there, all I have left on the top is sand. It's a little bit wet, but that's okay. So now we're going to take the filter paper out of the funnel, and you remember we kind of folded this. Now we can kind of unfold it gently and place it on the watch glass right there. Again, that watch glass lets us hold it there nicely and store it for whatever else we might use it for. The last step says that we're going to dispose of this. If this were a chemical that we wanted to keep for whatever reason, we might take some sort of tool and scrape it off. But in this case, we don't really need this sand. We're just going to dispose of it in the trash after that.
At this station, we're going to learn how to heat substances using the ceramic hot plate. We have our thermometer. You're used to measuring temperatures in Fahrenheit, but now you have to get used to Celsius. For B, because we're working with changing temperatures and trying to get something to boiling, we're going to don our beautiful safety goggles. We've got a little grabber claw that we can use to pick up glassware, like an Erlenmeyer flask, which is letter D. And they come in different sizes. Our ceramic hot plate is letter E. This has a power cord just like our electronic balance, but some of the models have two different wheels. One of them will change the temperature and the other one is a magnetic stir function. The power cord will get put into the back just like we saw for the balance. Then we've got our hot mitts. These will keep your hands safe because hot glass looks like cold glass. You don't want to scald yourself. And then we have our graduated cylinder, which is letter G. Again, they come in different sizes. Because we're working with a hot plate, I want to make sure that I'm using proper safety precautions. So I'm going to cover my eyes. Notice that my goggles go very comfortably over my glasses. My hair could potentially be a fire hazard, so I want to make sure that I clip it back or ponytail it back. And then these sleeves are dangerous. They can knock over glassware or they could catch on fire. So if you forget and you wear these kinds of sleeves to lab, we'll probably give you a rubber band so that you can pull those sleeves into place to make sure that they're not flopping around. For this station, we are going to measure out water and then we're going to heat it up using the hot plate, and we'll show you two different ways to move hot glass. So I will measure out 40 milliliters of water. When you are measuring out water using the graduated cylinder, recall that we are trying to line up the scoop at the bottom of the liquid that's called the meniscus with the measurement on the grad cylinder. And I still need just a smidge more. Good. Okay, I'm going to transfer that to an Erlenmeyer flask. The Erlenmeyer flask can be heated safely. It's a good type of laboratory glass that can withstand temperature changes. On the back of my hot plate, there is an area to connect the power cord. You would normally keep this facing your belly, but I'm going to turn it around just so that you can see the display that's on it. We are to transfer the 40 milliliters of water in the Erlenmeyer flask to the top of the hot plate, and then we're turning on the heat to 400 degrees Celsius. That obviously is quite hot. When this is heating, it could potentially catch anything that's near on fire. So we want to move all papers, make sure your sleeves are out of the way, and the cord of the hot plate itself should not be laying on the hot plate. Last year we had 2 cords that melted a little bit, and that's very dangerous. It does take a while for this to heat up, so we'll come back when it's heated. Now we see that our water is boiling. I want to take the temperature, but to keep myself safe, I'm going to turn off the sensor and now unplug the device. Our thermometers are alcohol thermometers. There is a scale for Fahrenheit and a scale for Celsius. Boiling temperature for water is 100 degrees Celsius. So I'm going to carefully stick the bulb of the thermometer into the Erlenmeyer flask. And the red alcohol that is in the tube is skyrocketing up on both of these scales. I'm going to see how high it goes. Because the water is still boiling, I would expect it to end somewhere around 100 degrees Celsius. The lab asks us to record what the actual temperature is. Mine has stopped at 98.5. And so I would write 98.5 degrees Celsius down on my paper. I can take this thermometer out and set it off to the side. To transport hot glassware, I want to protect my hands with these gloves. So I use the hot hands and carefully grasp the glassware and set it down on the counter. We also have the ability to use different specialized tongs. These ones that are smaller are good for glassware that has thin necks or crucibles, because I can grasp it gently, it gets stuck by the lip of the glassware, and then I can transfer it. We also have beaker tongs, which would not work very well for this thin Erlenmeyer flask for obvious reasons. If I try to grab the bottom, it's not going to be stable, and you can see how the glassware narrows at the top, potentially causing a dropping hazard. This would, however, work very well for a wide mouth glassware beaker, so sometimes we'll utilize it in that context by grabbing around the top. When you are done, make sure that the glassware is completely cooled before pouring the water out. Set all of your tools aside and take your hot hands and goggles off.